Okay, so in our previous video, we have already stopped at the question number 5. So today we are going to continue with question number 6 until we finish the whole chapters. Yeah. Okay. So question number 6 sounds like this. A graph of log ionization energy against the number of electron removed for period 3 Q is shown below. So this is period 3 elements. So I do take notes that this is period 3 elements. Okay. Okay, so based on the graph, number 1, explain the position of element Q in the modern periodic tables. So if you look carefully, so you have 1, 2, 3, 4, 5, 6 before the large gaps. This one. So in another word, this Q has 6 valence electron. So if it is a 6 valence electron, so that means that it is from group 16, okay, period 3, group 16. So you must mention together with the period because they want the exact position of the element Q. And the question did mention already that it has a period 3. So you must mention together Q is located at period 3, group 6, okay, group 16, sorry. Okay, so how do you explain it? So there's a large energy gaps between the 6 and 7 ionization energy. The energy increased greater than expected when 7 electron is removed. Okay, so this is how we deduce that. How do we determine which of the following is which of the atoms have 6 valence electrons? Okay, so with that is for number 6. A. Okay, then we continue for number 6B. So based on the answer in A1, write the electronic configuration of element Q. So you have to write out the electronic configuration S1, S2, 2s2, 2p6, 3s2, 3p4. B. Explain why successive ionization energy increase gradually. So in here, you have to explain why is it that the ionization energy increase gradually. Okay, so in here, as electrons are removed, your screening effect decrease. So when your screening effect decreased, your effective nuclear charge increase. So that is why the ionization energy eventually increase. Okay. C. Element Q forms simple ion when electrons are received. So write an ionic equation to show the formation of simple ion Q. So in here, Q, because it's group 16, it will ready to accept 2 electrons to form Q2 minus. So you have to write the ionic equation and compare the size between atom Q and ion Q. Based on the comparison, explain your answer. So you have to mention that ion Q, because Q is anion, so anion is greater than its atom. So you have to mention that Q2 minus, sorry, not Q minus, sorry for that. Q2 minus has a larger ionic radius than Q. Okay, so why? Because the screening effect inside the Q2 minus is greater, therefore the effective nuclear charge is lower. Okay, or you say the octet arrangement in the 3s and 3p orbitals cause the screening effect to increase. Okay. Okay, so that is how you are going to answer question number 6. Immediately we go to question number 7. Question number 7 sounds like this. The formula and the melting point of some oxide of the elements in the period 3 Na to Cl are given in the table below. So you have the compound and the melting point. Given the formula of an oxide to have the following structure. Number 1, giant covalent and simple molecular structure. So in here, giant covalent is definitely SiO2, yes. And for simple covalent, simple molecular structure is either P4 or 6 or SO2, either one. Okay, so number 2, give the formula of one of these oxides which give no reaction with water when placed in for a long time. So in here is either aluminium oxide or silicon oxide. Okay, and since they want formula, you better write your answer in formula. Okay, okay, so that is for 7A, 1 and 2. 7B, melting point of the silicon to chlorine are given below. So we are back to the elements again. Explain why melting point of silicon is much greater than the other elements. 1, because silicon is held by giant covalent structure. And number 2, suggest why the melting point of 3 other elements are in order from sulfur to phosphorus to chlorine. Okay, so you have to mention, first of all, you have to mention their nature. So chlorine exists naturally as Cl2, phosphorus exists as P4, sulfur exists as S8. And then they are all simple covalent molecule held by weak van der Waals forces. Okay, so as the molecular size or molecular mass increase, so the strength of the weak van der Waals forces also increase. Okay. So that is how you are going to explain why is it that the elements melting point increase in such order. Okay. Okay, so with that, that is for question number 7. Question number 8. An element in the period 3 exhibit periodicity in both chemical and physical properties. So a graph of atomic and ionic radius of the third period is shown below. So this is the graph. Explain the decrease in the atomic radius across the third period. So in here, why does the atomic radius decrease? If this is the line, so that you have to take notes in here. Okay, I highlight with the blue line. Okay, so why is the atomic radius decrease? So nuclear charge increase as proton number increase, while screening effect remain almost constant as the number of shell occupied is the same. Therefore, effective nuclear charge increase. So if effective nuclear charge increase, that is why the atomic radius increase. Okay. Okay, so that is for 8A1. 8A2. Explain why from phosphorus to chlorine ionic radius are greater than atomic radius. So in here you have to mention as the number of as electrons is added, screening effect increase. So as screening effect increase, effective nuclear charge decrease. So that is why the ionic radius is greater than that of the atomic radius. So the first ionization energy of element across the third period show a generally increasing trend. Aluminium and sulfur do not follow this general trend. So explain why aluminium has a lower first ionization energy than actually is why aluminium has a lower first ionization energy. So you have to use it is because it's structure, so it is better for you to say that magnesium using the balanced electronic configuration. So magnesium is 3s2, aluminum is 3s2, 3p1. So the partial field 3p orbital of aluminum is less stable compared to the full field 3s orbitals inside the magnesium. So if you want, you might want to complete your sentence. Okay, so this is how you complete. Okay, and similarly, why sulfur has a low first ionization energy than phosphorus? Same reason. So write the balanced electronic configuration first. So phosphorus is 2s2, 3p3, while sulfur is 3s2, 3p4. So we said the half field 3p orbital in phosphorus has extra stability, or you can even answer as the electron pair in sulfur. Okay, so the orbitals in the electron pair occupied in the 3p orbital in sulfur repel and cause the electron to be easier to be removed. So that is how you can either answer in such a way. Okay. Okay, so with that, that is how you answer all the structure questions for number 1 until number 8. So immediately we goes into the essay questions. So hopefully we can learn on how to solve the essay questions, all of them. Okay, so let's have a look at the essay questions. So in part C, essay questions. So we have that. Okay, so question number 3 sounds like this. Magnesium, aluminum, silicon, phosphorus, and sulfur are elements from the third period in the periodic table. Melting point of the element is given below. So these are the melting point. Explain the trend of the melting point in terms of bonding and structure. So in here, you must know by yourself what are the structures that occupy inside this element. So magnesium, aluminum are held by metallic bond. While silicon is held by giant covalent structure, while phosphorus and sulfur are simple covalent molecule held by weak van der Waals forces. Okay, so you must have the way of how to explain them. So why is it that aluminium, you must compare, why is it aluminium has a slightly higher melting point than magnesium? And then in terms of comparison, why sulfur has a slightly higher melting point than phosphorus in here, okay? So if you know how to tackle this point, shouldn't be much of a problem for you to learn how to explain this essay, okay? So it's a 10 marks worth of essay, so make sure that you write your points to the fullest. So first of all, you have to mention that this is a very unexpected marks, because magnesium, aluminium, silicon, phosphorus, sulfur are solids under room temperature. Okay, so it is a very tough marks. Most of the students will usually neglect this point. Okay, so you still have to mention this. Okay, try your best. Okay, so magnesium and aluminium are whole by metallic bond. Okay, so aluminium has a slightly higher melting point than magnesium because aluminium has more balanced electrons than magnesium, therefore can delocalize more electrons. Okay, therefore has a greater metallic bond strength. As for silicon are giant covalent molecule. Okay, giant covalent structure. So each silicon is covalently bonded to 4 other silicon atoms via sp3 hybridization. So this is a statement that I always encourage students to write whenever you are trying to explain the giant covalent structure inside the group 14, regardless of carbon, silicon, and germanium, because this is technically the way of how they are hold to each other, and that is why they exhibit a very high melting point. Okay. Okay, then for phosphorus sulfur, you must mention how does their nature of the molecules. So phosphorus exists as P4, sulfur exists as S8. Okay, so they are simple covalent molecule hold by weak van der Waals forces. And then since the molecular size or molecular mass of the sulfur is greater than the phosphorus, that is why the strength of the van der Waals forces is greater compared to the P4. Okay, so that will be more or less all the 10 points worth of the essay marks that you might want to take notes in here. Okay, I do encourage you all to try your best to write more inside essay questions. So just try your best and describe as complete as you can. But generally, when we describe their bonding and structure, these are more or less the points that you have to mention when you are explaining in between these elements in here. Okay. Okay. So with that, that is for 10A. Number 1A, sorry. Then it goes for 1B. Alloy of aluminum and magnesium has a high tensile strength and low density and are often used in aircraft manufacture. When a 1.0 gram of sample of one of such alloy was treated with an excess aqueous solution of NaOH, 1.0 gram of 1.0 decimeter cube of hydrogen gas measured at 25 degrees Celsius, 1 to 1 kilopascal, was produced together with an aluminium containing product which is the same as obtained from the reaction of aluminium oxide with sodium hydroxide. So write the equation for the reaction of aluminium with sodium hydroxide. So this one is you have to know how to balance between the reaction of aluminium oxide, and the question did mention that containing the product same as obtained when from the reaction between aluminium oxide and sodium hydroxide. So between aluminium oxide and sodium hydroxide is NaLOH4, okay, and you at the same time you release hydrogen gas. So the question did mention what are the products that you form throughout the reaction. So you must be able to write the balance equation in here where you have 2Al plus 2NaOH plus 6H2O give 2NaLOH4 plus 3H2. Okay, so that is for number 1. And number 2, what is the percentage of aluminium in the alloy? So first of all, you have to calculate the mole of the hydrogen gas. So you use PV equals to nRT. So N is equals to 101 times 10 power 5 times 1.00, because it's decimeter cube, so you have to substitute to meter cube. So that is why you have times 10 power negative 3. And then, as usual, substitute as exactly given to you in the questions. Okay, divided by 8.31 and 298 Kelvin. So mole of aluminium stoichiometrically is 2 to 3. Okay, so the mole, stoichiometrically 2 aluminium is to 3 hydrogen. Okay, so the mole of the aluminium is 2 over 3 times 0.048 equals to 0.0272. Okay, then you calculate the mass of the aluminium, so 0.0272 multiplied by 27.0, so you get 0.734. And then finally, you calculate the percentage. So 0.7734 divided by 1.00, you get 73.4%. Okay, so this is how we are going to answer to calculate the mass of the percentage of the aluminium inside the alloy in here. Okay, so that is for number 1. Okay, immediately we go to question number 2. Enthalpy of vaporization of lithium, nitrogen, and fluorine are given in the table below. Discuss the variation of the enthalpy of vaporization for lithium, nitrogen, and fluorine. Okay, so in here you have to discuss the enthalpy change of vaporization. Basically, it's the same technique of how you explain the melting point. So first of all, you must know what is their structure in here. So in lithium, it is held by the metallic bond, and then whereas it's for nitrogen and fluorine, they are held by simple covalent molecule held by weak van der Waals forces. Okay, and if you look at their enthalpy change of vaporization, they does not differ much. So why is it that they does not differ much? So you also have to explain that. Okay. Okay, so first define the enthalpy change of vaporization. Yes, every time when you have when they ask you to describe enthalpy change, you better define first. Okay, you better define first and even write the equations. Okay, so enthalpy change of vaporization is the energy absorbed to change one mole of substance from liquid to gas. Okay, so lithium is held by metallic bond. Okay, so where electrons are delocalized from the lithium metal and interact with the interaction between the electrons delocalized and the lithium ion form the strong metallic bond. Okay, okay, then we have sodium and nitrogen and fluorine are simple covalent molecule held by weak van der Waals forces. So the weak intermolecular forces of nitrogen is slightly higher than fluorine. It is true. That's why you have a higher vaporization due to the smaller size of the nitrogen. Okay, but whatever it is, just try your best to explain. Okay. Okay, sorry for that. And that is for number 2A. Okay, immediately we go to 2B. Okay, to 2B, you have to be careful. So read the question carefully. The question already stated that the variation of melting point of the oxides of elements in the period 3 oxides. So the question already highlighted that is oxide. So you better be careful with the oxides in here. Okay, of the periodic table is shown below. Explain the variations in terms of the melting point in terms of structure and bondings. So you have to know on how to compare the oxides melting points in here. Okay, okay. So generally there are also 3 structure inside here. So the 3 structure inside here are number 1, you have between this. Sorry, I just highlight using the circle. Okay, so these are one structure itself. Okay, between Na2O, MgO, and Al2O3. Then this one is a structure by itself. Okay, and finally this one is a structure by itself. Okay, so you must know very clearly that what are the what are the intermolecular forces inside in between them. So these are giant ionic crystal lattice. Okay, and then SiO2 are giant covalent structure, whereas phosphorus and sulfur are simple covalent molecules. Okay, so once you understand on how they are structured, then it will be easy for you to explain their bonding. Okay, so let's start from the giant ionic crystal lattice. So in here you have to mention that Na2O, NGO, and Al2O3 has giant ionic lattice structure which are held by ionic bond. Okay, and then why is it that the trend looks like this? You also have to explain. So sodium ion has a lower charge and larger ionic radius than magnesium and aluminium. That is why they have the lowest melting point. Whereas aluminium ion, since there is a high charge density and high covalent characteristic, so that is why it has a slightly lower melting point compared to the magnesium oxide. Okay, so this is the reason why aluminium has a lower melting point than the magnesium oxide. Okay. Okay, then silicon is held by giant covalent structure where each of the silicon is covalently bonded to 4 other oxygen atoms. So try your best to explain in such a way. Okay, while phosphorus and sulfur has a simple covalent structure held by weak van der Waals forces. So since the molecular size of the P4O10 is greater than SO3, therefore they have a greater strength of the weak van der Waals forces. So that will be more or less on how you are going to explain why is it that the melting point variations goes in such ways. Okay. Okay. So with that, that is for number B. Then we go to the C. Aluminium oxides can react with acid as well as a base using suitable ionic equation. So the question already highlighted that you must write your equations in terms of ionic equations. Explain why aluminum oxide can react as well as a base. Okay, so you have to mention first of all, aluminum oxide is an ionic compound with high covalent characteristic. Okay, so aluminum oxide is an amphoteric oxide. So because if you look at the statement, it only mentioned aluminum oxide can react with acid as well as a base, but it does not say aluminum is amphoteric, isn't it? So in another word, you have to mention by yourself that aluminum is an amphoteric oxide. Okay, so why is it aluminum is amphoteric? Because it is an ionic compound with high covalent characteristic. Due to you might want to add this. Okay, due to the small size and high charge of aluminum. Okay, they cause a high charge density. Hence high covalent characteristic. Okay, so that is how you want to explain as fully as you can for aluminum. Again, last but not least, you write the ionic equation. In here, we only accept ionic because the question already mentioned that it is ionic, so you must use ionic equation only. We're going to erase this. Okay, sorry for that. Okay, so you have to write in terms of ionic equation because the question already mentioned that you must write them in ionic. Excuse me. Okay, so with that, that is how you are going to answer for essay question number 3. Okay, so with that, that is how you answer the essay question. We continue to the next question. So the next question is question number 3. Question number 3 sounds like this. Table below shows the formula of an oxide ion with proton number 7 to 13 except for 10. 1. Sketch a graph of ionic radius against proton number 2 marks and explain the graph sketch. So in here, you have to know the trend of the ionic radius. You have to know by yourself how does the trend of the ionic radius goes. So in here, generally decrease. Okay, so you have to sketch the graph in a generally decreased trend. Okay, and then explain why is the graph looking like that. Okay, so why is it the graph looking like that? Okay, so you must all mention that these ions have the same valence electron, therefore same electronic configurations or same number of electrons, therefore isoelectronic. Okay, therefore isoelectronic. And then as you can see here, the proton number is actually increasing. So when the proton number is actually increasing, but the screening effect is the same because they are isoelectronic, therefore the effective nuclear charge increase. So when the effective nuclear charge increase, that is why the ionic radius increase. So if you know how to describe in such a way, definitely you'll be able to score the full marks in here. So all ions are isoelectronic or the same number of electrons, hence they have the same screening effect. So as the proton number increase, the screening effect remain the same. Therefore, the effective nuclear charge increase. So that is why the ionic radius decrease when going down through these points. Okay, so that is how you are going to explain for question number 3A. Okay, immediately we move to 3B. Sodium, magnesium, aluminium are first 3 elements in period 3 of the periodic table. Compare the electrical conductivity of these 3 elements. So in here, you have to use the ability to delocalize the electrons. So how you describe in terms of that? Okay, so first of all, you have to mention that all these three are held by strong metallic bond, where each of them delocalize electron to form the electron C that interact with the metal ion. And then you start with, always start with the valence electron first. Only with the valence electron, then you'll be able to explain the number of delocalized electron increase. So when the number of electron delocalized increase, the strength of the metallic bond also increase, therefore increase the electrical conductivity. Okay, so that will be the technique of more or less the same of how you are going to answer that. And if possible, because you have 6 marks, that's quite a lot of marks. So you might also want to define what is metallic bond. Okay, so as I always remind you all, you must try your best to first define whatever statement that is given to you first. Okay, so since this is an essay question, you might want to write more. Okay, so in here, so you have to mention that sodium, magnesium, aluminium has metallic bond. So since the valence electron of sodium is 3s1, magnesium is 3s2, 3s2, while aluminium is 3s2, 3p1. Okay, so the electrons are delocalized from 3s for Na and Mg, and 3s and 3p for aluminium. Okay. So greater number of electron delocalized, greater the strength of the metallic bond. So that is why the electrical conductivity increase. Okay, so that is all the points that you might want to have in order for you to score the maximum possible marks for this essay. Okay. Okay, so this is number 3B. Immediately we go to 3C. Aluminium sulfate Al2SO433 is the active ingredient used in spray to relieve pain and swelling caused by insect sting. A 5.000 gram of sample of spray dissolved in water and found to precipitate a 2.047 barium sulfate, which treated with an excess aqueous solution of barium chloride. So what is the percentage of aluminium sulfate in the spray? So in here, you have to first write the equations. Okay. So the equations in here, is balance. So Al2 SO4 3 plus BaCl2. So you form you have this one, you have 3, yeah? So you form 3BaSO4, okay, plus 2AlCl3. Okay. So that is how you write the valence equations in here. So from here you can see the stoichiometry 3 to 1. Okay. So from the mole of aluminium, so it's stoichiometrically is 1 to 3. So you have to multiply with 8.78 times 10 power negative 3. So you get 2.93 times 10 power negative 3 mole. Therefore, mass of the aluminium is 2.93 times 10 power negative 3 multiplied by 342.3, or you get 1.002 gram, and then only then you calculate the percentage. So 1.002 divided by 5.00, you get 20.0%. Okay, so please also write the equations. I forgot to mention that you must write these balance equations in here. Okay. Okay, so with that will be more or less the way of how you are going to solve for essay question number 3. So immediately we move to the last questions, which is question number 4. So for the elements sodium to phosphorus, describe the reaction, if any, that occur when separate samples of each element was burned in air, and then water is added to the resulting oxide. Suggest the pH of the aqueous solution formed and write the equation where appropriate. So in here, there are 2 things you have to write here. From sodium to phosphorus, describe when samples of each element are burned in air, and then the oxide is added to water. So there are generally two reactions in here. Okay, so you have to try your best to describe as fully as you can in here. Okay, so first of all, you have to mention that sodium burns in air to form sodium oxide or sodium peroxide. Either one are accepted. Okay, whereas magnesium also burn in air to form magnesium oxide. So aluminium and silicon generally, to be honest, they generally don't burn in air. But for aluminium, you still try your best to write. So 4Al plus 3O2 give Al2O3, while silicon form SiO2. Okay, and then finally phosphorus form P4O6 or P4O10. Okay. Okay, then you dissolve all these elements inside water. Okay, so Na2O plus H2O give 2NaOH, or if you use sodium peroxide, is Na2O2 plus 2H2O give 2NaOH plus H2O2. So the pH of the solution, because of NaOH is a strong alkali, so you have pH between 13 to 14. Then magnesium oxide dissolves sparingly in water, so that is why you have a reversible equations in here. So you form magnesium hydroxide. So the pH is somewhere between 8 to 10. But aluminium oxide and silicon dioxides are insoluble in water, so that's not this one. Whereas phosphorus oxide dissolve in water to undergo hydrolysis. So P4O6 plus 6H2O form H3PO3, or P4O10. Sorry, this one is supposed to be 10. Plus 6H2O form H3PO4. Okay, so the pH is somewhere in between 1 to 4. It is a triprotic acid, so you should expect a lower pH in here. Okay. Okay, so with that, that is all the points that you should be able to write in here. So just try your best to describe as fully as you can for all the reactions inside here. Okay. Okay, so that is for question number 4A. And then 4B, in submarine, sodium peroxide is used to absorb atmospheric carbon dioxide and to regenerate oxygen. Sodium carbonate is formed as a byproduct. Okay, so number 1, construct a balanced equation for this. And if submariner exhales 600 decimeter cube of CO2 per day, what is the mass of sodium peroxide is needed per day to absorb CO2 produced by the crew of 8 submarines? So there is a key in here that you might want to highlight. So there are 8 submarines, so you have to multiply by 8 at the end of the day. Okay, so first write the balance equation. So Na2O2 plus CO2 give Na2CO3 plus half O2. If you don't want to leave as half, so you can write 2, 2, 1, 2. Okay. Okay, then mole of carbon dioxide. So you have 600% for 8 submariners. You divide it by 24.4. So you get 196.7 mole. Okay, so stoichiometrically, 1 CO2 is to 1 Na2O2. So mass of the Na2O2 is 196.7 multiplied by 2 times 23.0 plus 2 times 16. So you get 15.3 kilograms. Okay. Okay. In here, does not necessarily must be leave your answer as kilogram. It can be grams. So 1.53 times 10 power of 4. 1.53 times 10 power of 4. Okay, so with that, that is how you answer essay question number 4. So immediately we goes to essay question number 5. Hydrogen may act as a reducing agent or oxidizing agent depending on the substance react with it, using in turns sodium or chlorine as the other reactant. Write a balanced equation for the two reactions and describe the redox role of the hydrogen. Okay, so in here when react with Na, so hydrogen in here will act as an oxidizing agent. So according to the equation, 2Na plus H2 give 2NaH. So in here, you have to try your best to describe what is the changes of oxidation state from 0 to +1. Okay, and hydrogen change from 0 to -1. Okay, so try to describe as fully as you can. Okay, whereas for when react with chlorine, so hydrogen act as a reducing agent. So according to the equation, H2 plus Cl2 give HCl. When here oxidation state of hydrogen 0, chlorine also 0. HCl hydrogen is +1, chlorine is -1. So that is how the role of the hydrogen behave in sodium and behave in the chlorine here. Okay. Okay, so that is for 5A. Then immediately it goes to 5B. When magnesium burns in air, it forms two products of A and B. A react with water to form a basic solution, while B react with water to form a similar solution of A plus a gas with a pungent odor. So explain this observation, has identify A and B, write the equation for the reaction. So inside, this is a very tricky part of the question, because when burned in air, it forms two products of A and B. So some of you must be wondering, so what is the two products in here? And air contain what? So don't forget, in our air is a mixture of what? 78% of the nitrogen and 21% of the oxygen. So in another word, magnesium burns separately nitrogen and oxygen. Okay. So, and that is where everything begins. So that is why in here you have two products. So the further continuations of the question says that A react with water to form a basic solution, while B also react with water to form similar product, okay, than A, plus a gas with a pungent odor. So pungent odor is basically trying to describe ammonia. Okay, so explain the observation, hence identify A and B right equation involved. So you must know that A contain majorly nitrogen and oxygen. So A is the magnesium oxide. Okay, so while B is the magnesium nitride here. Okay, so why does it form a basic solution? Because A dissolve in water to form magnesium hydroxide according to the equation. MgO plus H2O give MgOH2, while which form as white precipitate. I'll explain the observation. Okay, so you have to mention that you form a white precipitate. So MgOH2 is a white precipitate for information. Okay, and then pungent smell in here is ammonia. So where Mg3N2 react with 6H2O, you form MgOH2 plus 2 ammonia in here. Okay, so that is how you are going to describe all the questions inside here. So this chemistry, you must try your best to understand them. Okay. Okay, so with that, that is for question number B. And then finally, we have C. The first four ionization energy of element D in the period 3 are approximately 738, 1450, 7.7 times 10 power 3, and 1.1 times 10 power 4 kilojoule per mole respectively. Explain the position of element D in the periodic table. So you must try to analyze by yourself. The big gaps is in between the second ionization energy and the third ionization energy. Therefore, the position is the group 2 period 3. Okay, group 2 period 3. Okay, so why is it like that? So because due to large energy gaps between the second and third ionization energy, so an electron is extracted from the inner shell. The third electron, supposedly, third electron is extracted from the inner shell here. So that is why you require a high ionization energy due to the great increase in the effective nuclear charge in here. Okay. Okay. So with that, I guess that is all for the video sharing session today. So basically, we have one more essay questions to discuss. So